Assalamu alaikum. Hello everyone. My name is Mansur Asmin and today I am going to talk about a very important concept in our operating system, that is process synchronization. In modern computer system, multiple processes often run at the same time. But these processes sometimes need to share resources like memory, files or device. To ensure this process works smoothly without causing errors, we need process. But what is process synchronization? Process synchronization is the coordination of concurrent process to ensure correct and predictable access to shared resources. But without synchronization, we may face some problem like race condition, like data inconsistency, like unexpected system behavior. To avoid all this, we must ensure only one process enters the critical section, the part of the code access shared resource at a time. But there are some conditions for proper synchronization. There are three key conditions that must we meet, and first one is mutual execution, progress and bounded waiting. In mutual execution, only one process can access the critical section at a time. On the other hand, on process, if no process is in the critical section, then other should not be unnecessarily delayed. On the boundary waiting, there should be a limit on how long a process wait to enter the critical section. So now think about an real life example. Think that of an ATM machine. If two people try to access same bank account at the same time without coordination, the balance may become incorrect. So we need to proper control, just like synchronization in computer. So now let's talk about race condition. So a race condition happened when two or more process access shared data at the same time, and at least one of them is trying to change the data. This leads an unpredictable result. It's like two people writing on the same whiteboard and at the same time it's become mess. So how to prevent it? We use some tools like mutex, Simforce and automatic operation. So mutex is like a mutual execution that allows only one process at a time in the critical section. Semaphores is a counting tool to manage how many processes can access a resource. On the other hand, automatic operation is small code that can't be interrupted in the middle. So let's next see about producer consumer problem. So this is a classic example of synchronization. This is producer adds data to shared buffer, and on the other hand consumer takes data from the buffer. So if the buffer is full, the producer must be wait, or if the buffer is empty, then the consumer must be wait. But there have some challenge also, and that is if the producer must not add data, and if the buffer is full, the consumer must not remove data, and if the buffer is empty. But we can solve this problem using semaphores. A semaphore to count empty space in a buffer. A semaphore also count full space. It's like a mutex of ensure only one process can access the buffer at a time. So the guarantee safe communication between the producer and consumer is good. Now let's talk about the dining philosopher problem, and it's a very interesting problem. And like this problem demonstrate synchronization issue such as deadlock and starvation. So let's imagine a scenario for a good about dining philosophy problem. So think about five philosophers are sitting at table, and each philosopher need two forks to eat, but there is only one fork between one pair. If each philosopher pick up one fork and wait for to the others. None of them can eat, and that is deadlock. But is there any solution? But yes, there is solution. It has solution, that is use semaphore or mutex to control fork access. So apply symmetric resource allocation. For example, like philosopher will even numbers pick up the left fork first, and then odd numbers pick up the right fork. So limit the number of philosopher at a table to avoid a circular weight. And as we know that there are some common synchronization tool, that is mutex, as we say first, that is mutual execution, and that is semaphore and monitor. So in mutual execution, ensure only one process access at resource at a time, as we first before said. And semaphore is signaling mechanism to control access and using counting, like for multiple access, or binary for single access. On the other hand, monitor is a high level construct that combine the mutual execution and condition variable to manage process and interaction more easily. So but how avoiding deadlocks? What is the solution? How avoid deadlock and starvation? To ensure all process get fair access, we can use, that is resource ordering, timeout, and bounded waiting. In resource ordering, request resource in a predefined order, and a timeout is if a process waits too long, it gives up and tries again later. And on the other hand, in boundary waiting, set a maximum number of times that other process can enter the critical section before a waiting process gets its turn. So about all, we can say that process synchronization is essential for ensuring that multiple process can work together without conflict, and it helps prevent errors, improve performance, and ensure data integrity in multiple process and multi-threaded system. So by using tools like mutex, semaphores, and monitors, and by carefully designing process interaction, we can easily solve common synchronization problems such as race condition, producer consumer, and dining philosopher. So that's all for me, and thank you for your attention.